Remember the absolute chaos of old device connectors? A time when every device seemed to speak a different language. Every gadget had its own uniquely shaped cable, a proprietary plug, and absolutely nothing worked together seamlessly. It was a frustrating landscape of incompatibility. Then, USB-C arrived on the scene. One port to rule them all, one cable to connect everything. Problem elegantly solved. Today, the world of AI integration is, unfortunately, just as messy and convoluted as those old cables. Every new AI model and application needs its own custom-built bridge to connect to anything else. This quickly spirals into the infamous N times M problem. Imagine 10 models, 10 apps, and suddenly you're grappling with 100 individual integrations. The complexity explodes exponentially. It's a huge, unacceptable waste of valuable time, precious resources, and developer sanity. That's why we're introducing the Model Context Protocol, or MCP. Think of it as the universal USB-C, but specifically designed for the world of AI. MCP is a completely open standard, ensuring interoperability and fostering innovation. It's designed so that any AI model or application can connect to the broader ecosystem with just a single integration. Now, instead of painstakingly building and maintaining 100 complex bridges, you simply build one integration per model and one integration per application. And then, everything just seamlessly works together, effortlessly. When a groundbreaking new AI model launches, you can simply plug it in and watch it go. No extensive rewiring or custom configurations needed. Developers can finally redirect their focus to building innovative features and enhancing user experiences instead of endlessly fixing broken connections. MCP elegantly transforms a tangled, unmanageable mess into a clean, highly scalable, and easily maintainable system. So how does MCP actually make this magic happen behind the scenes? What are the core components and how do they interact to create this seamless experience? Let's dive into the architecture and explore the inner workings of MCP. There are three main roles at play within the MCP ecosystem, each with a distinct responsibility. First, we have the host, then the client, and finally the server. The host is essentially your application, the software that you're building or using. It could be anything, maybe a chatbot designed to assist users, or a sophisticated design tool empowering creativity, ultimately wanting to leverage the power of AI to enhance its capabilities. The client component resides inside the host application, and it speaks the MCP protocol fluently. Its primary job is to take the application's requests and translate them into a standard format that the server can understand. The server, on the other hand, exposes the AI model, making it accessible to the outside world. It diligently receives the request from the client, processes it using the AI model, and then sends the results back to the client. All communication between the client and server travels over a flexible transport layer. This could be WebSockets, HTTP, or any other suitable protocol that fits the specific requirements of your application. MCP itself doesn't concern itself with the specifics of how the data moves. Its only requirement is that the data adheres to the correct, standardized format. This means the host application doesn't need to be intimately familiar with the AI model's internal details, and conversely, the AI model remains blissfully unaware of the intricacies of the application it's serving. The client and server components take on the responsibility of handling all the necessary translation and communication, effectively making the entire system plug and play. This clear separation of concerns means you gain the flexibility to swap out AI models or even entire applications with minimal hassle and disruption. The result of all this? A predictable and standardized workflow that simplifies integration and promotes maintainability. Integration becomes fast and efficient, the architecture remains clean and well-defined, and your technology is future-proofed against evolving AI landscapes. MCP's power, its versatility, and its effectiveness all stem from four core concepts that form its foundation. These concepts are the key to understanding how MCP operates and how it can be leveraged for a wide range of applications. Tools, resources, prompts, and sampling. Tools are the AI's skills, the specific functions it can perform. They include abilities to summarize information, conduct searches through vast data sets, perform complex calculations, and much more, depending on the tools available. When a host connects to the MCP ecosystem, the server meticulously lists all of its available tools, providing a comprehensive inventory of its capabilities. This ensures that the application using MCP knows exactly what's possible and can effectively utilize the AI's potential. Resources are the data, the raw materials that fuel the AI's processes. This includes a wide array of file types such as documents, images, and even source code. These resources are the foundation upon which the tools operate, enabling the AI to perform its tasks. The host is responsible for providing these resources to the AI, for example, providing a PDF document that needs to be summarized. Prompts are structured instructions, carefully crafted to guide the AI's actions. They act as the bridge, tying the available tools and resources together in a coherent workflow. An example of a prompt would be, summarize resource A using the summarize tool. This structured approach ensures that the results are more reliable, consistent, and predictable. Sampling controls the AI's creativity. It determines how much freedom the AI has in generating its output. This is managed through parameters like temperature or top P, which influence the randomness of the AI's choices. A low temperature setting results in a more focused, factual output, minimizing creative deviations, while a high temperature setting encourages more creative and imaginative results. MCP standardizes the way you set these dials, providing a consistent interface across different AI models. This standardization gives developers precise control over the AI's style and output. With these four fundamental building blocks, developers gain both the flexibility they need to innovate and the consistency required for reliable performance. Every interaction within the MCP framework is designed to be clear and transparent, making it powerful, yet easy to manage and integrate into existing workflows. That's how MCP ensures that AI remains grounded in practical applications and consistently delivers useful results. Security is non-negotiable when connecting AI to sensitive data. MCP uses OAuth 2.1 with PKCE, the gold standard for secure authorization. Apps get only the permissions they need, nothing more. Capability-based access means fine-grained control. Use this tool on this data for this task. Input sanitization protects against prompt injection and other attacks. Everything runs on a zero-trust model. Every request is authenticated and validated. With MCP, security is built in, not bolted on. What does this mean for real-world teams? Integration timelines shrink from months to days. Maintenance headaches disappear. MCP-compliant connections just keep working. Companies save time and money, freeing engineers to innovate. As an open standard, MCP lets everyone compete and collaborate on a level playing field. Developers aren't locked in. They can mix and match the best models for every job. The community shapes MCP's future, building a vibrant ecosystem like USB or HTML. MCP is the foundation for the next generation of AI, open, flexible, and built for everyone.